Looks like there's a lot of folks kind of coming in. Are you guys getting a lot of feedback? Or is that just me?
Yeah, it was a little staccato, I suppose.
Seems better now.
Yeah.
Okay, hopefully.
Or not. I just get some feedback myself.
Just a reminder to everyone, please keep yourself muted unless you're asking a question. Hopefully once I mute myself, the feedback will end. But welcome and thank you all for joining. Looks like we have quite the crowd today, so that's exciting. We're here for the reproducible reporting in R series, or R cubed if you're fun. It is being, originally it was for the working group, the Northwest Atlantic Regional Sea ICES working group, which focuses on integrated ecosystem assessments between the US and Canada. And we were able to expand on that as everything's remote. So welcome all. I'm Kim. I am a contractor with the Ecosystem Dynamics and Assessment branch at the Northeast Fisheries Science Center. And we had a time slot that Ben could use. So I'll help just organize all of this, but definitely questions towards Ben. Ben Best is going to be leading this course. He's an environmental data scientist with a background in marine spatial ecology. He's got his undergrad degrees from UC Santa Barbara in aquatic biology and geography, and his master's from Duke in marine science and conservation. He worked on the OBIS CMAP project, which is a spatial portal for observations on marine mammals, seabirds, and sea turtles. And now he works at his consultancy, EcoQuants, which helps and the IE program with data automation, visualizations, reporting, and more for the IE program. So it looks like people are still rolling in, which is still exciting. And I got mad lag.
Yeah. Sorry, Kim, it's cutting in and out a bit. Maybe it's just with all the people joining. And I love seeing familiar faces, especially here, but I don't know if that would affect if people are sharing their video, if it would affect sharing their video and sharing her video and audio. But I can also pick up where she left off. So I don't see video there, but it looks good. So yeah, let's go ahead and get started. I am going to share a link to the website with materials that hopefully you guys all have. And I'm in process with adding the link to the slides, but I'll put that in the chat here now as well. And sorry, it's a long link, but and without further ado, I think I'll get started and yeah, with sharing my screen. Yeah, screen. Okay, so thank you all so much for your interest and attending. Please be sure to mute if you're joining so we don't get too much distracting background noise. And so, yeah, this is a reproducible reporting using R and otherwise R cubed because that's a mouthful. And the website is here, and I just put the link to the slides in the chat. And yeah, Kim introduced me, but I'm gonna guide you through some of these techniques for using R to create reporting techniques and visualizations and collaboration techniques for especially producing marine ecological indicators. And today we're going to really just focus on some nuts and bolts with the foundation for where we're going to conduct exercise and build materials. So I'm just going to ask that you please mute Marcio, Felipe, if you could mute, please, that'd be great. Thank you. So yeah, let's just do an overview of where we're going and why we're here. So this working group on the Northwest Atlantic Regional Sea is supporting integrated ecosystem assessments across the Northwest Atlantic region, inclusive of Canada. So Department of Fishery, or DFO, is involved, and then NOAA's Integrated Ecosystem Assessment Program that has a Northwest branch where Kim Bastille, who was giving the introduction, is based out of. And so there's a term of reference, and we were actually slotted to do this workshop last year in person at Dartmouth. And then, of course, COVID hit, and now we're regrouping and thought it would be great to also open this up across the IEA program in general, and really anybody who wants to attend because of this online format. We can just open up to everybody. So the idea is to develop best practices for increasing efficiency and product development, leading to responsiveness and management. So how do we go from data to reporting on these indicators and making that as palatable and digestible from a general audience to a scientific and a management audience that can make decisions about how to use our natural resources best. So the IEA program across NOAA has this nice little graphic to describe how they go through this process of defining goals and targets, developing those indicators, assessing the ecosystem, analyzing uncertainty and risk, and going through strategies. And it's a circle because it's very much an iterative approach. And this is a graphic taken from a paper that Kim actually led on improving the IEA approach using principles of open data science. So where along that wheel can we use techniques of open data science to automate and facilitate these processes? So that's what we're going to focus on for the next 8 weeks. And the other experience I have that's most related with this is working on the Ocean Health Index led by Ben Halpern out at UC Santa Barbara and the National Center for Ecological Analysis and Synthesis there. And this was a fairly ambitious project that took all the publicly available data across 10 broad goals and globally, and assessed each marine exclusive economic zone's sustainability from everything from biodiversity to food provisioning to natural products to clean waters, etc. So that was a big exercise in learning how to take data and create indicators that are hierarchical in nature and want to be reproducible year after year. So this paper was led by Julie Lowndes, and this was our experience with trying to repeat this analysis year after year and realizing that these tools that we're going to go over in this little course were actually somewhat nascent. RStudio it was sort of a new player when we were first playing with this stuff, especially the Shiny framework and the tidyverse of packages. But using this combination of Git to version things and GitHub as the online portal to store those changes, and then collaborating with each other and moving forward year after year, we noticed that the amount of time to do the data science, while there was an initial hurdle of that data science, say in 2013, 2014, it became less and less as it became more and more reproducible, and the science got easier to then interpret those results and report out over time. So we're able to collaborate and reproduce our results more easily. And if we look at like data science writ large, it's generally this Venn diagram of hacking skills intersecting with math and stats and intersecting with some substantive, that's the blue circle, substantive expertise. So you look at that intersection of math and stats with substantive expertise, and you get traditional research. If you don't have any stats, then you're just hacking away at data, then you're in the danger zone. And if you don't have the substantive expertise, then maybe you're more of like a computer scientist individual. Then maybe you're doing machine learning. And so the sweet spot is that intersection of data science. So an environmental data scientist is then taking those programming and stats skills and combining it with these substantive area expertise on ecology, evolution, species distributions, connectivity, laws and regulations, and that sort. So R for Data Science is a really fantastic book by Hadley Wickham, who's like the demigod of the tidyverse. Originally it was called Hadleyverse because he created all these packages. He started with the grammar of graphics and plotting, and then moved into generally just bringing packages together that have a consistent thinking with how you can sequence operations to do these basic tasks. So R has a rich history going back to the 70s in Bell Labs, and Tukey was a statistician there, wrote a book on exploratory data analysis, and that was originally how R was conceived, was to be able to quickly look at your data, look at outliers and anomalies, and evaluate patterns and quickly plot things. So it wasn't in the vein of traditional computer science, and then S+ became commercial, and R then went back to its roots, or the founders had the first letters R in their name, but regardless, it became an open source product, and then RStudio came along and really innovated on top of there, and then there's been a whole ecosystem of technology that's really evolved since then. So Python is probably an even more popular scientific programming language, but it's interesting how they learn from each other. So R had a data frame years back that could combine different columns of information, which seems like no big deal with Excel, but that was kind of new to scientific programming. And then Python came out with pandas, which does the same thing as an R data frame. And now R is innovated with something called a tibble, where you can actually have tables inside of a single cell, and then even any other kind of list object, whether it's a linear model in another cell and then a plot in another cell. So, and then there's ways of iterating over many rows and columns, and you get this powerhouse of automation with R that's, I would say, also more oriented towards speed than it is computer science, like hardcore principles. So if you're okay with a little flexibility in some of the non-standard evaluation, then R is pretty great. And I would say that there's also some really excellent reporting utilities with the innovation of Rmarkdown that works with this thing called Pandoc to create not only HTML outputs, but PDFs and Word docs from the same source document, embedding formatted text in the form of Markdown with chunks of R that get evaluated and render plots and tables, etc. And then a lot of that interactivity is really enabled by the innovation of all these really cool visualizations happening through the web. So D3 is a data-driven document JavaScript library that was like a really progenitor starting a decade ago by Mike Bostock. And a lot of the really cool visualizations you see in major newspapers like the New York Times and the Washington Post really borrow from that. So those JavaScript-based web libraries can then be folded into this HTML widgets framework and then be output into any HTML or Markdown document. And you don't need to know HTML and JavaScript and CSS and all that. You can just input your data and a few other arguments, and you're kind of off to the races. So that's really means that we can stay within a, relatively speaking, within a common language to generate all the products we need. And then Shiny is another way of communicating out when you need more user interface interaction, but requires a backend server to then take those inputs from the user and then render arbitrary outputs with functions on the backend server. So I know I'm speaking kind of fast. I want to cover a lot of ground. All of these materials will be recorded and posted online with the main website. So you can always go back and rewatch things. And I would say that's also a great way to take this in. So you can just kind of like let things wash over you and then go back, and we have exercises with each of these lessons that you can do with a little bit more time. Yeah, I'm gonna see, I'll narrate this so I don't mess up the audio. But this is really, I think, an amazing 1-minute video worth checking out. So what is Rmarkdown? It's an authoring framework for data science, and you can connect to the data, run the code, generate all these different reports. It has 3 types of content, these code chunks, text and Markdown, and then front matter that is in this YAML format that we'll go over. So you can generate this output and use Python and other languages as well. And the Rmarkdown render function allows you to render in those different output formats. And this is a web example. Yeah, and you can even change the formatting of that Markdown. The knitting with parameters allows you to then use that same template and update a variable that might change, in this case, the location of where you're doing it. And these are all the different plethora of products that you can generate from just an Rmarkdown document. So very powerful. And we're looking at the RStudio IDE, and this is actually the version control system mentioned there. So yeah, wow, that was cognitively weird having him talk in my ear while I was talking back. So hopefully that made some sense. But I encourage you to check out the slides. You can visit and go to that link directly. And Garrett Goldman at RStudio does a pretty amazing job. And I would say that, you know, I'm a big fan of RStudio, but I don't get any funding from them. They're a public benefit corporation founded by JJ Allaire, and half of their engineers work on open source products and half on enterprise products. That's how they fund it. And so I think it's a pretty interesting model for creating long-term legacy in that the code is never going to be proprietary, and things have a pretty lively network of contributors. So why I called this thing the reproducible reporting using R workshop because actually my dad was a mechanical engineer, and he worked on high-speed automation of machines, and he had this little thing invention called RoboDisk, which basically took the assembly line approach, and a pallet normally it goes through an assembly, and then robots or humans do each thing one at a time, and then he basically connected the pallet to the robot head and had a semicircular array of things that then so it was like a microfactory. Anyway, enough of that, but he taught workshops on like how he thought, which was actually matching needs with capabilities in this automation space. So I think we're actually doing a fairly similar thing. We're trying to say like, okay, what are our reporting needs with developing marine ecological indicators? and then how do we automate that in a way that delivers on those needs based on the capabilities of the tools we have at hand to do that. Yeah, so this is an overview of the schedule. We're going to collaborate, so use Git and GitHub in RStudio, and then we're going to manipulate with this tidyverse of packages to read data in, wrangle the data with dplyr and tidyr. Then we're going to visualize data with the grammar of graphics plotting, and then use some interactive widgets or HTML widgets like Plotly and Diagraphs to output especially time series plots. And then we'll look at some mapping functionality for both vector, which is points, lines, and polygons using the spatial features package, as well as the some gridded data or the raster package and outputting to an interactive mapping interface with Leaflet. Then the reporting that's with Rmarkdown, which I've introduced, and then a variety of other output types. And then finally, GitHub has a similarly interesting model. It got bought by Microsoft in the last few years, but they work on a freemium model. So as long as you store your code on github.com and make it publicly available, then you can use a lot of these services for free. But then they are funded through the enterprise development of software development where people want to make it secure or private, and then they have to pay. So with that, by making code publicly available, then we can also take advantage of things like GitHub Actions, which allows us to use this continuous integration feature of software development to actually go back and re-render our outputs to go, say, fetch the latest data and then render the latest plot or map. So yeah, it's a pretty interesting feature now. And then with the IEA, they have developed a lot of conceptual models of ecosystems where each of the elements in the ecosystem, let's say the whale or a thermometer for a temperature, is displayed as an icon. And then we created a little JavaScript library to allow you to click on the icon and pop up a little window that shows you some of the data associated with that. So we'll go over creating those with these JavaScript and R packages. And then we'll go into using Shiny with some applications. And then finally, all this stuff the building blocks really are using functions, which is just a reusable piece of code that allows you to enter in some parameters and then spit something back out. And then there's a consistent way to document functions using these other packages. And we'll go over how to do that to help you with the building blocks and share these things out. Okay, so for feedback, I'm hoping that Kim is still with us and she can interrupt me at any time with a specific question. I really encourage you all to use the chat and feature, and then you can raise questions, and you can raise your hand to speak, and I'll rely on Kim to narrate there and or control that. And then there's the slides here, and you can actually go in and comment on the slides if anything was unclear. And then there's a Google Doc where you can add questions, suggestions, or references. It could get a little hectic with a lot of people editing at the same time with cursor wars, but I encourage you just to create a new bullet and then try to type within that bullet. So this is a experiment in progress on how to do these things. So we will just see what works and really rely on your feedback. And then hopefully by the end of today, you'll be able to actually use GitHub to also provide feedback. So there's GitHub issues to create, and you can also even directly suggest edits by creating pull request. So that you don't have write permissions on this repo, but you could create a pull request. That would ask me to accept changes. We'll go over that. Or you could just email me, ben@ecoquants.com. So without further ado, I'm going to go ahead and dig in because I'm realizing we're almost already into half of the hour. So we're going to go over how to use Git, GitHub, and RStudio. And the problem with sharing files, especially if you just want to exchange with a collaborator and you want to send files, say over email, is that it becomes very messy, as I'm sure you've experienced, between keeping track of the different versions of files and you don't know who's edited what when, even with using track changes in Word. And really a solution to that is having a common repository where then that's always available online, and any changes that are made, you can push and pull to exchange those changes. And then if there's a conflict, then you can proceed with dealing with it, but hopefully it seamlessly merges portions of files that you aren't simultaneously editing. And then there's other ways that we're going to go over about how to even isolate your environment and then systematically review. So this is the way it works is you have files that get changed in a version control system, and then you're always committing those changes with a message. And those changes then go through a little algorithm and generate a hash. And that's the unique identifier. So I could be offline and make some code away, then I'm online and I've made the commits, and then I push that back up to the central repository, and then another collaborator could come along and do the same thing, and then we're going to reconcile these commits. And you might have heard of blockchain technology with like cryptocurrencies. This is actually a very similar approach. We're pushing a block of information in, getting a little hash out associated with each commit, and then we're sequencing those together. It's not as strict with distributed ledger stuff as needing an exact chain, because people can insert commits before and after if there's no conflict, but it's actually similar in concept and implementation. So these are the main tools. Git is a command line utility, and meaning it's run, let's say, on terminal on a Mac, or it's run in a MS-DOS prompt on Windows, and they are specific commands: git and then clone, or git and commit, git and push, git pull. Those are specific commands to do the work that we're going to talk about. And then GitHub is an online repository that does a really good job of facilitating the conversation and doing the project management associated with sharing files and versions of files. RStudio is our integrated development environment in which we can write our code, and it's got some basic user interfaces to do the basics with Git. So it's actually just a user interface that then sends those commands you see on the left to the terminal after you input it in the easier to use interface. So we'll go over that. And it can be rather confusing. I'm not gonna lie. It takes some mental sifting to get through it, but this is all, you know, human-made stuff that has a rationale behind it. So we're going to try to focus on some of that rationale and then present a few different workflows or modes in which you might use Git and GitHub in RStudio to get things done. Yeah, and you'll learn by degrees, and you learn by doing, and you basically Google your errors, and you end up on Stack Overflow or some other really useful resource that somebody posted online. And that's just kind of the nature of how this stuff works. So patience and persistence is key. But let's just talk about, before we dive into the lesson, let's talk about a few different workflows in broad terms. So you might want to pull and push. So if you have created a repository on GitHub, and hopefully you've set up a username at github.com, that'll be really key for this. And hopefully you have an RStudio. Let me just point you to the setup here on the main website. So a GitHub account would be good, a Google account, even using, you can click on these links to see the latest versions of stuff. You don't need a new Gmail or anything. You can actually associate an existing email with the Google account. And then these are the other clients with with links to the latest versions that you could download and install. If you don't have install privileges, then on your machine, like a government issued laptop, then you can also use RStudio Cloud, and you get up to 15 hours for free of use, and it presents an entire RStudio interface that has Git on it, and so you can actually use that instead. So yeah, so let me get back to this presentation. And so there's this pull and push, which is the simplest scenario. And I have a table that kind of describes in more detail all the specific Git commands. If you don't have write access and you want to just contribute to, say, some sort of any open source project that's publicly visible on GitHub, excuse me, then you can fork that, which basically copies it into your own GitHub writable owner space, and then you have write permissions there, and then you update it, and then you request that some owner of another repository, the original repository, then pull those changes into theirs. So it's a fork and a pull request, and they're funny terms, but they're trying to be short and sweet and simple with what it's doing. Now, the other thing that even if you can directly write to a GitHub repository, and a repository is just a collection of files that you want to edit, and it might have folders or not, and subfolders, but if you want to work with others and you want to have like a sort of a production output separate from, say, a development iteration where you're working on let's say, fixing a bug or implementing some new feature, then you might want to do this branching. And so when you branch, it isolates, takes a snapshot of those files when you branch it, and then you can work on it, continue to make commits or changes to those files, and then merge it back into the original main branch. And so that allows you to isolate yourself from others that might be working on different bugs or features, etc. And also the production main branch that maybe is publicly visible that when you've sorted everything out. So these are different workflows, and they're increasing in complexity, and the exercises work through different examples of going through these. Now the fully pro version, which I think is a little much to totally get to, but it's really just adding, if it's implementing all of these at once. And so you can go to this GitHub guide, which describes each of these pretty nicely. But when you branch it, so this would be the main branch in the solid blue line. And when you branch, you're kind of branching a copy out of it. And then each of these dots is a commit that you're changing files to. And now you might actually do the pull request. And the pull request, even though you can maybe even write and accept and merge changes already, what it does is it advertises what you're doing to the rest of your collaborators. And then you can use GitHub to have a discussion about those changes before you do the final merge. So that's the total pro setup that I would advocate getting to, but you kind of got to do baby steps along the way. So it kind of makes sense. So with that, I'm going to go ahead and dig into what are an exhaustive amount of materials that is going to be a little bit of a challenge, honestly, to get through within the remaining hour, because I do want to allow time for discussion, but we'll see how far we get. I go through a lot of detail in explaining each of these steps in the documentation, but what I'd like to propose doing is going through all these steps, talking through it, and you could just watch and let it kind of wash over, and then we could have some discussion about it, and then you'll have time to then go over it yourself and do it yourself. And the upshot of where we're going to go is really similar to this website. So this is an Rmarkdown website hosted on GitHub. Whoops, let me go to the actual GitHub one. Hosted on GitHub, and it's got a little menu up here, and well, on this training site, you're going to be populating a different menu item as we iterate through each of these schedule items. And here's the actual GitHub view of that website. And you wouldn't have, so every GitHub repository has an owner and then a repo name. And then that's what we see here with Noah-IEA and then R3 train. And there's a way then to use this website to then host your own, or use these source files to then host your own website. And it's basically going into settings and pages and then turning this on. So where we're going to go is you're going to have your own user writable space, and my GitHub username is bbest. And then if you look at the most recent repository, I just sort of archive this, and we'll populate some basic pages using our Markdown, really simple stuff, and we'll use these techniques of pushing and pulling those to create this simple website. And we'll create the repository. You'll create something like this. It'll be just called R3-exercises. I changed the name of this so that I can create a fresh one with you live. And then you'll also do that pull request by updating a roster. And this roster is based on just a little CSV file here under data roster. I have links to all this in the exercises, but here's my GitHub username, my full name. And you'll notice that even GitHub does a nice thing here where it shows it as columns. The raw data is just a comma separated value table, which is like the most common table. And you'll add your own GitHub username and where you created the website of the exercises with your full name. And then I will, as a pull request, and then I'll accept that and re-render this roster, and we'll see, how people are doing if they're able to get through this amount of exercise that I'm throwing your way. Okay, so without further ado, I think I'm gonna dig into some of these lesson materials. So there's a lot of text here. I'm gonna breeze through, and hopefully you'll have this as reference material to dig a little deeper. I went over how this is structured with an owner and a repo. Every GitHub repository. Now the owner could be a user, like here I'm bbest, or it could be an organization like Noah-IEA. So that it could be either one, but it's actually quite simple. It always has this pattern of owner/repo, and then this simple push and pull. These are the Git commands that we'll use, and we'll use the RStudio interface as much as possible to do this. We'll create a repository, and that will live then on GitHub, and then we will clone the repository, which then brings it from the GitHub space onto our local machine, onto our local PC. In this case, I'm putting it in a GitHub folder just on my user drive, which is the tilde. And we clone it. And then the next step is now we're going to make some changes to those files. We're going to edit those files so that the commit happens locally on the machine, and then we push it back to get it from our local machine up to GitHub. And then if other people or other machines that I'm on are editing that, then we pull it back down. So that all sounds groovy in the abstract. Let's go ahead and dive in and do that. So each of these little functions or Git commands has some help to help guide you, as well as, and I'll revisit these other modes of fork and branch and merge, as well as these exercises. So I'll try to queue up where I'm at. Here's a little bit about opening up your RStudio and terminal and setting up your username. And whenever I say user in this document, it's referring to your username. So my username is bbast, but whatever your GitHub username is, you'll want to substitute wherever you see that. And then, so what I'll go ahead and do is start with this 1.3 step. And let's see if I can go to my user space, so GitHub, and I'll be alternating between a web browser and this RStudio interface and how to do this. So here in the upper right, because I'm signed in, I have this option to create a new repository. So I'm going to create an R3 exercises repository. And I think I even suggest yeah, and here's like a little description where you can even provide a link to the website. We're going to make this public, and we're going to just tick the box to say add a README file, which we're going to go over in a second. So we'll create this repository, and now here we have a repository. So there's a lot of stuff to kind of take in here, but the main thing is that it has one file, README, and it's showing you what was the message of the last commit associated with that file and when was it committed now. This is that little hash associated with that last commit. That is a unique string about those changes. And also a README is unique in that on GitHub, it shows you the README, which is really like, it's meant to be a guide about what's in this folder. So you can always add a readme.md, and at the bottom, it will actually display it. And what we're seeing here is we click this pencil, and this is actually, it's shorthand for writing HTML. And this little, when a line begins with a hash, that's a header. We have a URL here, which automatically converts to a link. We can preview that. We can even change a few things, like I could say website here, and that's the Markdown for creating a link with text. So that is now we're editing directly within GitHub. And what I want to move to next is I'm going to not do that just yet. I will do it later. Is now it's on GitHub, and now what I want to do is clone this or copy all these files, which is just one, into my local RStudio environment. So I'm going to launch RStudio, and so I'll launch it. So this is the training website you see, and it's got a lot more little tricks in it. But we're gonna go to the File, New Project, and this is how we're gonna use RStudio for two things. And I discuss what these two things are here with the Create RStudio project, these two things in 1.4. So we're gonna use the version control on a Git repository. And this repository URL, there's a little trick to easily grabbing that. And the trick is here, you can click on that little green button from your repository and take this URL, which ends in a .git. It's the same URL with just a .git at the end. And then we'll paste that, so that clicking on the clipboard, put it into my clipboard, and now I can Control V or paste here. And it's going to default to project directory name of the same name as the repo. And I just happen to put it in the subdirectory. You can browse to wherever makes sense on your machine. I like putting it in my home folder with GitHub, and then maybe the owner of the repository, and then slash, it'll create this folder inside. So I'm going to create this project here. Oh, I already created it, so let me just move that real quick. So GitHub, best. Oh, because I think I had it open. Okay, let's try that again. File, new project, version control, Git, paste again, and create project. And now what it's done is it's run, that went really fast, but it actually ran a git clone command to clone it into that folder. And we see here I'm in GitHub best, our 3 exercises. And this is also a lot to take in if you haven't seen RStudio yet. But there are some also fantastic cheat sheets. We can go up to RStudio help and look at these cheat sheets. And here's the RStudio IDE cheat sheet. So it's online as a PDF, and we can open this PDF and see that it's describing, here's where we write code, here's some more support, and we can have version control, and the console is actually where code gets executed. I encourage you to check out these cheat sheets, and I will highlight the different panes within this RStudio environment as we work with them. So if we go to the Git pane, then there's a few things. One is we see the README in the Files pane, and so that was already versioned. And we see these question marks, and it's saying, in Git, is saying, okay, do you want me to version these? I don't know about these files. They haven't been added to my system to track them. And so what we're going to do is click, and then it goes from a yellow question mark to a green A for add. And then we're going to commit these. So we're going to say, okay, add, so we're going to say plus rproj. So this rproj, it's just actually a simple text file. But when you install RStudio, it associates that as an executable to open it up, that R project. So I'm going to commit this. And now I've committed those changes locally. And you'll notice that it says your branch is ahead of the origin by 1 commit. So now I can either from that commit window, we see that the green up arrow is associated with the push. So now we're going to push from my local machine those changes to GitHub. And now if we go to the website, we see that, okay, now I have this rproj file and this git ignore. So the git ignore is just a simple text file that says ignore these hidden files. So Windows Explorer and Mac Finder wouldn't normally show you files, but they're in there, and that's just so that you don't. It's just keeping track of local temporary things. So there's the console, and the other reason that we really like an rproj file is that we can click and open up RStudio in this environment where this is the working directory. And what that means is any files that you put in this is if somebody else clicks on that rproj file and you use a script or anything that references something relative to that location, it will work regardless of where they put it on their machine. So a relative path is different from an absolute that's starting, let's say, with the C drive and going forward. This is saying, okay, relative to here. So with that, we've done our first clone. We've actually done this full cycle. I can do a pull, and there's been no changes online. And that's the push-pull model, basically. Too many tabs. It's a problem I have. Okay, so we finished this first example of creating GitHub repository 1.4. We created the RStudio project, and we did this really simple commit and push. And so now what we're going to do is create just a default Rmarkdown. We're not going to go too much into the details of Rmarkdown, but you can use, there's an awesome cheat sheet on diving deeper. We're going to go into it more, certainly in the future. But let's create an index.rmd. So I'm going to say file, new file, Rmarkdown, and I think I say, and we'll call it R3 exercises. And we'll say, okay. And this is that same aspect. This is actually in this YAML format for the front matter, which is just a way of, it's sort of a programming language agnostic, a way to configure variables that can also be hierarchical. So we're saying, here's the title, author output, here's a little chunk of our code, here's that formatting. So this is a header level 2, here's a link, this is going to be bold and knit, and here's another chunk. And without further ado, let's go from, let's save this as index, and that will automatically show up now index.rmd. Git is asking me like, oh, do I version this? We will do that in just a second. And then we'll knit this file, and now we see, okay, we've got a title, a header. Here, this is showing me some output on the summary of this cars dataset that's natively loaded, and a plot. We'll get back to Rmarkdown and all that stuff. For now, we're going to focus on using Git and exchanging files with a central repository. So now let's go in and save. We knitted, and we're going to add this. We're going to add this to our repository. We're going to commit this, and we're going to say, okay, add index. So we add that, close, push. And now, because I pushed it, it's up on GitHub. And we see that, sure enough, here it is. So then the question is, moving on to this step, how do we make this a website? So by default, index.html is served by any dumb web server when you go to a folder. And how do we turn that on? Well, we go into the settings tab of the GitHub repository, and we then scroll down to this pages, and we're going to select the branch, and we'll get into branching in a bit, of main, and we're going to go ahead and go with the root folder and click save. And now it's saying, okay, your site is ready to be published. It's HTTPS because it's automatically enforcing that security. GitHub handles that for you. And let's take a look. So it says your page isn't here. One of the reasons behind that is GitHub. It takes a minute or so to render because GitHub Pages were originally designed as a blog kind of entry. And there's this whole other framework called Jekyll that we're not going to use. So we can turn this off, and I show you how to use this. Go to terminal and touch it, this file in RStudio, but you can also just add this file, create a new file, and we'll just call this dot, so it's a hidden file, no Jekyll. And so if I create that file here, then we have this dot no Jekyll, which is going to speed up the rendering of the actual website. And because I committed that and it had this default message, because you always need a message with a commit, I don't need to push it. It's already on GitHub. It's on the origin or the central repository. But now we can try this link again, and there it is. So now we have a live website that we can share with the rest of the world that has our report of interest. So we can click on this cog, and now I can even update this website here. And you'll notice that it's basically rearranging the source repository on GitHub, that URL. So instead of github.com, it's github.io. And instead of github.com/owner, we put the owner before, and then we have the repo after. And you can actually use this technique if you create a repository called owner.github.io in your user space, that will then default to the default website. But that you can do on your own. For now, we're just doing these. So we have now a little website. Okay, cool. So we've got a website, but it doesn't really lend itself to having multiple pages. So how are we going to do that? Let's emulate what we already have on the NOAA training site, and we're going to use something, a first flavor of Rmarkdown called an Rmarkdown website, and you can find out all kinds of stuff about Rmarkdown, RStudio, and these are the different formats, and this is an HTML, and there's a lot of documentation on this. But suffice to say, we're gonna tweak what we just did, and you can always go back to different versions of files. That's the beauty of the version control system. And we're gonna, we're gonna do that, but actually, let me take a break because we're at the hour, and there's more exercises continuing on. And so let me just say that here, the other in-between mode that we're going to do is do this fork and pull request. And then, so you can contribute to any repository that you don't even have access to or write access to, starting with this training site to update that roster. And then there's a little bit about creating this Rmarkdown website with this more professional technique of isolating it in a sandbox by branching it, making some changes, and then updating that output. And you'll use some more YAML or markup language to configure that website in the navigation bar, and some really basic Rmarkdown, or really just Markdown, to then render that site. And then you'll create an issue and deal with actually resolving a file conflict. And this gets into using GitHub for project management. So by creating an issue and then just having a number and then the issue number in your git commit message and then pushing that up, it's going to associate those exact file changes with that issue. So now you can have a line-by-line discussion about everything that's changing. And then finally, you can create a little project board of multiple issues in this Kanban style. So you can organize what you're working on next, sort of top down. And that's the biggest question in dealing with really complex projects, is what do I do next to sequence things, especially when you start working with others. So it's a great tool. So we're over the hour. Some people I know have to go or are already gone, and I do want to leave time for discussion. So I'm wondering if we can take a vote now about whether we continue on. I know this is way too fast. I'm reading sorry, I'm only reading the chat now, and I'm wanting to just get through a lot of material. So all of these, it's a totally valid point. All of these sessions are going to be recorded, so you can go back and listen. And it's sort of, we're always dealing with this trade-off of how much material do we cover versus how much do we keep everybody up to speed. So the hope is that there's enough written material to complement the speedy presentation material where you can kind of work at this depending on where you're coming in, whether it's you've already seen a lot of this stuff and you're trying to brush up, or you're new to it and you can go back and replay. So let's see. I don't know if Kim is still here. I could continue to.
Can you hear me now?
I haven't been reading through yeah, I can hear you now, Kim. Yeah. So I think I'll take a few just to, kind of gauge. I think that went pretty fast. Yeah. Kim, did you have some suggestions about directions next, or wanted to highlight some questions or comments?
Yeah, it looks like the chat is talking a little bit about how to connect Git to RStudio. Is there a link for that in your
Yeah.
presentation or in the documentation that we could drop into the chat?
Yeah. Thank you. That was a part I already have mine configured, so I should have flagged that as being an issue. So assuming that you have installed the in the setup on the website here, I'll put this. There's a link to Git, and I recommend downloading and installing this version of Git, and then wherever that installs, then it should tell you where it puts it. And the trick is then taking that path and going to Tools, Global Options, and then over here in this Global Options, we've got Git SVN, and then you browse to where that lives. So this is the executable. This is the command line utility that handles the Git back and forth. And I will supplement the setup in this collaborate with that information. So apologies for not including that.
There's another question, just a clarification. Explain like I'm 5. The difference between a pull and a branch.
Yeah. So this a pull, and this took me a while to wrap my head around. So it doesn't help to go through this as a blitzkrieg. So let's talk about it like more conceptually, and then hopefully that primes you to go through the tedium of the exercises. But there's a directionality with most of these commands, the Git commands that you're running. And a pull is going from the GitHub as the origin or the central repository, and it's pulling that into my user space. And that's going in this direction. So it's like updating my user space from the github.com online portal. And the branch is part of this. And see, it's kind of tedious to create these tables, and I'd only done it for the first 2. So I'll be populating that here as well. But the branching, what that does is it takes that branch can actually happen locally. And so it doesn't, it's assuming that you already have, you can actually do it on github.com and create a branch there, or you can do it locally on your local copy. But all it does is it checks out those files and creates a separate copy of them that you're then working on. And then it's under a different name. So maybe what I'll do is just zoom ahead to that part in keeping with this RMD website task. So I'll just show you that real quick in RStudio. And right now the default branch, it used to be called master, but I think for PC reasons they changed it to main. And that's the only branch we have by default in this Git pane. And so now when I pulled, I wanted to update because I added that little Node.jl file on GitHub. And so anyway, so the branch, here's the button to actually do the branching. In the branch, now I can put in a branch name and everything looks the same. So the files are the same as when I first branched. Nothing is showing up in Git except in the upper right, it's saying, oh, you're on RMD website, not the main branch. So now I can go in and totally change this so I can actually create this little website, and I'll just go ahead and do that. File, new file, going to create a text file, and similar to the front matter in an Rmarkdown document, this is just straight YAML, and this is what's going to be our navigation for the website that's generated. And then we're just going to create a little index. We're going to overwrite this index. So now we're actually going to see a change. So I'm still on this RMD website, and then we're going to create another little Rmarkdown. I'm just going to overwrite that, and we're going to call it collaborate. And then I will render this website. So I give it the package name, and then render site. And you might need to install this package, which you can do over here, packages, install, and then type Rmarkdown, which I also go over in the notes. And now it's going to render those sites, and now I can see this site, view in the web browser. So it completely overwrote the old index, but it's still only on my local machine. And now we're getting back to the branch. So I'm going to go ahead and check in all of these files. You'll notice that it added a site libs, which is where all the JavaScript stuff happened, and CSS. We'll worry about that later. So I just changed the files. New ones are A for added, modified ones are M, blue, and we'll say plus, or maybe a change RMD website. So I always have to add a commit message. I commit that, I close it, and then the next thing I want to do is now push it from my local machine up. So I'm still talking about the branch technique. And the reason is because if I go to my website and I refresh, it's the same thing. It's the old one. It hasn't changed yet. And if I go here and I refresh, it's actually, I don't have that collaborate file or the new HTML. And the last update was 15 minutes ago. Like, what's the deal? Well, here we have the branch again. And it's an isolated sandbox for then iterating on development. So the trick is then like, okay, well, how do I then merge those changes back to the main site and update my website? Well, now I can simply switch back to the main site. And now it's going to say file deleted. Don't worry, that's okay. We can close this because that the files might not even exist. So we're back to the main site like, whoa, what happened? It's kind of crazy to work with because it's its own hidden copy. And it's actually in this .git folder. That's where all the hidden mojo behind Git lives. But what we need to do is run this command. So far we've been using RStudio's user interface to do that. We actually need to go into the terminal and add git merge and then RMD website. And what this is going to do is merge those changes that we made into the main branch. So we're in the main branch, we're going to merge those websites. Wait, I think I forgot a step. Already up to date. Git branch. Okay, I'm on the main main branch. Git merge. Fetch sometimes updates. Okay. So git fetch is like a fancy git pull, and it gets all the latest information. So now I see this is part of the thing with git. Sometimes it's git merge. Huh.
A question related to this popped up in the chat. Is it possible to merge the branches from the GitHub website?
Yes, it is. Maybe that's what I should do. So sure enough, yeah, it's not working like I thought. This should merge. Weird. Okay, yeah, so we're gonna do that. So here, and actually, this is, you use the pull request, taking this method. So RMD website has a recent push, so we're gonna compare and pull the request, and we're gonna use that one message here, create the pull request, and this is the sophisticated way of doing it, and then merge that pull request, confirm the merge, and now it's successfully merged, so we can actually even delete that old branch, and that's how you would do it through GitHub. And now we see our new files here, and we can go to the website here, and you might have to do a hard refresh, but there it is. So apologies, that took a few iterations. Yeah. See you. Thanks, Pike, for joining. And feel free to chime in if you guys have specific other comments or questions.
It looks like there's
update this document.
Hi, Ben. This is Enrique. How are you? Thanks for the presentation. Very cool.
Yeah, thanks, Enrique, for joining. Yeah.
A very silly question, but I was wondering if you had a quick way of updating Git if you already have it installed in your computer and you want to do it through command line. What's the easiest way of doing that?
I guess the easiest way is to download Git here, and then the trick is updating RStudio to tell it under Tools, Global Options, where that updated Git lives. And the other thing is that you can create a GitHub issue. You can add comments into the Google Doc from the slides link I shared earlier, and we'll try to sort it. The best way to share the problem is to actually share error messages, as much information to provide as much detail so that your problem can be reproduced, and then we'll try to address it. Yeah.
Great. Thanks.
Yeah.
There's another question in the chat. Do we need to have the same project name / directory name in RStudio and GitHub for the push and pulls to work?
Actually, no. It's the default when when you create the new project and paste in the GitHub repo, when you go File, New Project, Version Control, Git, and paste that repo in there, that would be the default for the project directory name. It could be a different directory. The secret sauce is actually in that .git folder, is this config file. And this config file is telling it where that origin lives. So GitHub is the most popular repository, but GitLab, and there's like, you can have your own private server, but this is where it's getting the information about where it's synchronizing with pushes and pulls on that central repository. So that was a little bit too much detail, but I do move things around and I end up updating that URL in that .git config file.
Looks like we have about 10 minutes left. I'm not seeing any other new questions in the chat, but in case I missed any, feel free to pop in, everyone, if you have anything.
Yeah, and thanks folks for helping each other out, answering questions too. Yeah, this is great. It's a community open source thing to help each other get by. Yeah. And I know that was super fast. I think I spent too long introducing the overall course. So I will work on slowing down next time.
Yes, Ben, can I ask you for, at least to tell you a suggestion? Can you review the part? Can you review the part of creating the GitHub in R, because the slide is not very clear, and if you review the presentation, can you give us again a new version of this, please?
Yeah. So originally, here's the other problem is that there's so many ways you can actually go about this. So I'm kind of zeroing in on the ways that I use most frequently that seem to be really helpful. And so here I have screenshots about creating the repository on GitHub. And I tend to do this alternation between GitHub, the website, and then RStudio, my local software on my laptop. But once we create this website, and then I want to communicate that back. So what I did was I copied this URL by clicking on the green code button. And I'm in the notes, it's bbest is my username, so it would be your username after you created the repository. And it's the default code tab. So you click on the green code button, and then that gives you the URL here. Now I can click that little clipboard option, which just puts it into my clipboard. So it's just like Control C or copy. And now in RStudio, File, New Project, Version Control, Git, and then here's where I paste that URL. So this is the magic screen here to configure RStudio to tell it to go clone, use that git clone operation under the hood. And actually I could just put it in a different directory so it doesn't wipe over the old one, and it'll do it again. And I can even give it a different name. And I can even open it in a new section. And then I create the project. And now what it did, that what flashed before you is the actual command where it cloned it. And I have two monitors, so it'll open it up in the other one. But here it is. It's on my desktop. That was the folder name I gave it. It's those files in their current form. now in RStudio. So there's this files pane, there's this Git pane. Yeah. And this is interesting because, yeah. Mm-hmm.
Yeah, now I understand it because the first time you were very fast. Sorry. So now I understand what you have done.
Totally valid.
Thank you.
I know you weren't the only one, so yeah, thanks.
Yeah, thank you.
Maybe less coffee next time.
There was a question about if people are working through this, after this, where should they put questions? And I put in the Google Doc, but was that where you wanted people directed?
Yeah, that's great. So there's a lot of feedback options that I list, and apologies that this isn't yet on the main site. I'll just copy in this one more time. Actually, I'll copy it to the page for feedback. Because I just want to highlight, as you grow in skill level, you can actually create a GitHub issue in this main curriculum's GitHub repository. And what that allows for is us to have a conversation about it. So then I can create a commit with using that a hash or a number, $, and then that issue number. And then you'll see the exact changes that I made to the website to hopefully clarify the question. So that's like the ultimate pro way of doing it. But for now, you can add comments. We're going to copy and paste this chat. You can add even comments in this in the slides here, or you can go into this Google Doc where anybody can edit, and you can just go ahead and type. I know it's a little intimidating with all these different critters or people over here, but feel free to type away. I love collaboratively editing live. Google's great with that. So, or you can email me. Yeah, so maybe too many options. So I guess I would encourage you to try to see how far, if you have time available. I know it's already a lot of time, and apologies for, spending too much time, I think, on the overview. But if you have time, there's no substitute for actually doing this. And please communicate back with me where we need clarification on this documentation. This is meant to be a community open source thing. And there's also a ton of great other resources out there. I am definitely not the first person to talk about this. And some of them I would say, have done things really nicely. So this was just my way of being able to wrap my head around this stuff and processing it. But there's also, I'll add a bunch more specific to Git and GitHub here. I have them in some other notes. Yeah. Sorry, I think I heard somebody else starting to talk. Oh, thank you. Yeah, that was the one actually I wanted. Happy Gitter with R. So Jenny Bryan, she was at the University of British Columbia, and I even linked to this in one of the issues about how to resolve conflicts, or one of the exercises. And this is a fantastic resource. It's like written for humans, playfulness to it. Can you hear me now? Don't get too frustrated. And I think I link to here. And oh yeah, maybe the health section. Yeah, that's a good one. So happy. So yeah, dealing with conflicts. Wow, it's chapter 22. So advanced topic to be sure. And there's even a slightly different way that GitHub is recommending dealing with it than she documented. But that I show. But yeah, so this is actually the do not panic. This is like Hitchhiker's Guide to the Galaxy. The cover is do not panic. And yeah, it's a little messy when you actually have a conflict, but that is why we have a version system, is to be able to then mediate that conflict. Unfortunately, it's a little tricky to do. So in this exercise, I suggest creating an issue, and then when we resolve this conflict, then we will resolve that issue. So the way I have this is we are going to make a change on GitHub and say hello GitHub. And then before we do the poll of those changes in GitHub, we'll make a change in RStudio. And if we make changes and commit those changes in RStudio, then it's going to complain. It's going to give you this long message saying like, oh boy, it's not going to work, man. And what it does is it's showing you this U, which is unresolved conflicts. And it's actually trying to be very explicit, where above the equals, it's saying, here's what I have in the head. And the head is just the most recent commit on the origin. And then here's what I have locally, which is the most recent commit in my local version. And they're in conflict. You edited them asynchronously and before one knew about the other. And now we have to resolve this conflict. So it has this kind of funny look to it of the less than and then greater than to differentiate one version versus the other, the head versus the local version. So then you can modify, change it, see the difference from the old and the new. And then unfortunately, you have to use some terminal commands like command line in your terminal to then change those files. But when you do, then you use an issue that references number one and prefix, and before that number one says fixes it, then actually associates those changes with the issue, and all the line by line differences are displayed. So very powerful for collaborating.
We are right at 3:30, so I just wanted to say thank you, Ben. This is a ton of great information and a lot to chew on for sure. So thank you so much.
All right, thank you all so much. And I hope to see you next time. I hope I haven't scared you off completely.
Yeah, the next topic will be manipulate and dancing around the tidyverse. So that'll definitely be interesting and a great conversation for sure.
Yeah, thanks. Thanks so much, Kim.
So I'll grab the chat and drop in that document too.
Oh, thank you.
Because there's a ton of great resources in there.
Fantastic. Yeah.